What we're going to do here is we're going to set up I refer to as equilibrium bottles, and this is going to show phase equilibrium. We're going to take and add 100 milliliters of water to a 2.5 liter bottle, and I'm going to seal this up, and we're going to let it sit for about a month under heat lamp. To seal it, the inside seal is just plumber's Teflon tape. Don't want to have it too thick because that will crack the cap. Seals it there, and then we're going to take, this looks like adhesive tape, tape that you would use medically. It's called Malvus tape, and it provides an external seal so that the water is going to stay in the bottle. I'm going to set up a second bottle like this, and in this one what we're going to do is add naphthalene crystals. Okay, this is just crushed mothballs. Add these in here. Similar bottle. And we're going to seal this up in the same manner. If you want to store chemicals and they need to be sealed, this inside seal of Teflon tape works extremely well. You don't need the external seal. For this experiment, you want this external seal. Okay. Now what we're going to do is we're going to take these and we're going to set them here under heat lamps for about a month and see what changes occur. Okay, here we are, 1 minute simulated, or 1 month simulated later, and what we have is a setup now where we have the water at the bottom, but if we take a look, the heated side, we have all kinds of condensation. So the question is, how did that condensation get there? The only way is that the water at the bottom has evaporated, that has gone from a liquid to a gas, condensed up here. So what this does, this shows phase equilibrium, and this also illustrates the water cycle if you want to use it in showing the water cycle. And if you watch it carefully, you can get enough liquid that it rolls back down, see it here, into the main body of water below. The naphthalene, if you look at it, there is no liquid naphthalene in the bottom, it's just a solid, and yet we have a beautiful frost-like pattern of naphthalene crystals on the side. So this is an illustration of sublimation, where we've got the solid going directly to the vapor and then recrystallizing out here. So this is a phase equilibria, and very good for explaining how snow and ice disappears on a hot, sunny, or a cold, sunny day in the winter. When the sun is warm, the ice just evaporates directly into the atmosphere. And if you have some crystals forming on the outside of your windows or the inside of windows in cars, this is how this happens, and that'll take place. Okay. Okay, what we're going to do here is we're going to take a look at slightly soluble materials, and the most soluble of the slightly soluble materials is silver acetate. And silver acetate is actually, for something classified as slightly soluble, quite soluble, and you can have the students check the KSP of silver acetate by reacting a saturated solution of silver acetate with copper wire, if you can afford the silver acetate. So what we have done is created a saturated solution of silver acetate. Now, being saturated, there will be some silver acetate solid floating around in here. And so before you actually put some silver acetate into a beaker, you're going to have to filter it to make sure that there is no solid silver acetate in there, because you just want what's dissolved. So we're going to take 100 milliliters, that's 0.1 liter, of the silver acetate solution and pass it through a filter funnel and obtain 100 milliliters of the solution. Slightly over 100 milliliters. Just take that down. And we'll put it in a beaker. And we're going to put the copper coil into the beaker and allow the silver copper redox reaction to take place. The copper will become coated with silver and the copper metal will dissolve into the solution.
Mrs. Zemeck,
to show you what happens
2051, Mrs. Zemeck,
if you have
2051,
excess
Ms. Mertes is waiting.
silver acetate, what I'm going to do is put in 1/100th of a mole, that's 1.67 grams of silver acetate into this beaker to start with. And we'll see what happens with this, but we'll set it up the same way with 100 milliliters of silver acetate solution in the beaker as before, in the copper coil. Exactly 1.67 grams. You can read that, the formula mass, right off the labels, so you don't have to do a calculation. And again, I'm going to take 100 milliliters of the solution. Filtered, of course. Got it right on this time, and carefully pour it in to try to wet the silver acetate so that it stays within the solution. So we've got solid silver acetate here. And again, we're going to set up a copper coil into the solution and see what happens. Okay, this will take a day or two before we can come